Hi, today's topic is what is black hole and white hole. What is black hole and white hole? A black hole is a region in space where gravity is so strong that nothing, not even light, can escape its pull. It forms when a massive star collapses in on itself, creating a singularity, a point of infinite density and gravity. The boundary around the black hole, beyond which nothing can escape, is called the event horizon. On the other hand, a white hole is a hypothetical object that is the reverse of a black hole. It is a region of space where matter and energy can only leave, but nothing can enter. White holes are purely theoretical and have never been observed. They are predicted by some solutions to Einstein's equations of general relativity, but there is no observational evidence for their existence. It is important to note that white holes are purely hypothetical and are not confirmed to exist, whereas black holes have been observed and their existence is well established in astrophysics. How to form a black hole and a white hole. A black hole is formed when a massive star runs out of fuel and its core collapses under the force of gravity, creating a singularity, a point of infinite density and gravity. As the star collapses, it releases a tremendous amount of energy in the form of a supernova explosion, which can be observed from Earth. If the star's mass is greater than a certain threshold, known as the Chandrasekhar limit, it will continue to collapse into a black hole. A white hole, on the other hand, is purely theoretical and has never been observed. It is predicted by some solutions to Einstein's equations of general relativity, which describe the behavior of gravity. In these solutions, a white hole is the reverse of a black hole, where matter and energy can only leave, but nothing can enter. However, there is no known natural process by which a white hole could form. It is important to note that the existence of white holes is purely hypothetical, and no observational evidence for them has been found to date. Black holes and white holes are two completely different objects in astrophysics, despite their similar names. Here are some of the key differences between them. Formation. A black hole is formed when a massive star runs out of fuel and its core collapses under the force of gravity, creating a singularity, a point of infinite density and gravity. A white hole, on the other hand, is purely hypothetical and has never been observed. It is predicted by some solutions to Einstein's equations of general relativity. Gravitational pull. A black hole has an incredibly strong gravitational pull, so strong that not even light can escape it. Anything that gets too close to a black hole, including stars and planets, will be pulled in and crushed. A white hole, in contrast, is thought to repel matter and energy, so nothing can enter it. Observability. Black holes can be observed indirectly through their effects on nearby matter, such as stars orbiting around them. They can also emit radiation, called Hawking radiation, which can be detected by telescopes. White holes, on the other hand, are purely theoretical and have never been observed. Time. The concept of time behaves differently near black holes and white holes. Near a black hole, time is warped due to its strong gravitational pull, causing it to slow down. Near a white hole, time is thought to speed up, but since white holes are purely theoretical, this has never been observed. In summary, black holes and white holes are two very different objects in astrophysics, with different properties and behaviors. While black holes have been observed and their existence is well established, white holes are purely theoretical and have never been observed. The nearest known black hole to our solar system is called V616 Monocerotis, also known as V616 Mon, and it is located about 3,000 light-years away from Earth in the constellation Monoceros. V616 Mon is a black hole in a binary system with a companion star, and it was first discovered in 1992 by astronomers using the Japanese X-ray satellite Ginga. It is important to note that there may be other black holes that are closer to us, but have not yet been discovered. However, V616 Mon is currently considered to be the closest known black hole to our solar system. The size of a black hole is typically measured by its event horizon, which is the boundary around the black hole beyond which nothing, not even light, can escape. The event horizon is also known as the Schwarzschild radius, named after the German physicist Karl Schwarzschild, who first calculated it in 1916. The size of a black hole's event horizon depends on its mass. The more massive the black hole, the larger its event horizon. For example, a black hole with the mass of our Sun would have an event horizon about 3.7 miles, 6 kilometers, in radius, while a black hole with a mass of 10 million suns would have an event horizon about 18.6 million miles, 30 million kilometers, in radius. It's important to note that the size of a black hole's event horizon does not reflect the size of the singularity at its center, which is the point of infinite density and gravity. The singularity is thought to be a point of zero size, and its properties are not yet fully understood by scientists. It is not currently possible for humans or spacecraft to venture too close to a black hole without being destroyed by its intense gravitational forces. The gravitational pull of a black hole is so strong that it can warp space and time around it, causing anything that gets too close to be pulled in and crushed. If a spacecraft were to approach a black hole, it would experience what is known as spaghettification, where the intense tidal forces of the black hole would stretch the spacecraft into a long, thin shape like spaghetti. Eventually, the spacecraft would be torn apart and destroyed. However, it is possible for scientists to study black holes indirectly through their effects on nearby matter, such as stars and gas clouds. They can observe the way these objects move around the black hole and measure the radiation emitted from the surrounding matter. This allows them to learn more about the properties and behavior of black holes without risking human or spacecraft lives. Think if we dive into a black hole, then what happened with us? If a person were to dive into a black hole, they would experience what is known as spaghettification. This is a term used to describe the stretching and elongation of a person's body caused by the extreme tidal forces of the black hole. As the person approached the black hole, the gravitational pull would increase rapidly. This would cause the person's body to stretch out, with their feet feeling a much stronger gravitational pull than their head. This difference in gravitational force would cause the person to be pulled apart and stretched into a long, thin shape like spaghetti. Eventually, the person would cross the event horizon, the point of no return, and would be unable to escape the black hole's gravitational pull. They would continue to be stretched and pulled apart until they reached the singularity at the center of the black hole, a point of infinite density and gravity. At the singularity, our understanding of physics breaks down, and it is unclear what would happen to the person. Some theories suggest that the person's mass would add to the mass of the singularity, while others suggest that the person would be destroyed completely. It's important to note that this is a purely hypothetical scenario, and diving into a black hole is not something that can be attempted with our current technology. Black holes and white holes are both hypothetical objects in space, but they are not directly interconnected. However, they are related in a theoretical concept called a wormhole. A wormhole is a hypothetical tunnel-like structure in spacetime that could potentially connect two distant points in the universe. It is theorized that a wormhole could connect a black hole to a white hole, or even to another part of the universe. A black hole is a region of space where gravity is so strong that nothing, not even light, can escape it. On the other hand, a white hole is the hypothetical opposite of a black hole, where matter and energy are thought to be ejected outwards. It is thought that a white hole could be the other end of a wormhole that is connected to a black hole. However, the existence of wormholes is purely theoretical, and there is no direct evidence to suggest that they exist. Studying black holes and white holes can help us to better understand the nature of gravity and spacetime, and the potential for such hypothetical structures in the universe. Thanks for watching.